So let's take a look at 10.10 now. This is where we're starting to get into the questions that look at the structure of nucleotides and then DNA and things like that. And if we're going to memorize anything in this course, this is the important genetics course, the main introductory genetics course at Illinois State University. If we're going to memorize anything, well, we should probably memorize the structures of the nucleotides and the structure of DNA. So these are good questions to kind of test our memory. So I would memorize the nucleotides first and memorize how they fit together, and then take a look at some of these questions. So I need to brush up on the structures of these still, but let's see how much I can do without brushing up. So, okay, let's see. Draw the chemical structure of the three components of a nucleotide and then link the three together. Okay, the three components, what are those? So if we have a nucleotide, I should probably sit closer to the mic. So if we have a nucleotide here, what are the three components? Well, we need the 5-carbon sugar, right? Not 5 prime, just 5-carbon sugar. We make this a little thinner. We have the base, nitrogenous base. There's a lot of nitrogen in there. And we have a phosphate group. So to be a nucleotide, we have to have that phosphate group. Without that phosphate group, we're a nucleoside. Okay, so a nucleotide has a 5-carbon sugar, nitrogenous base, and a phosphate. And we are supposed to draw just the three components and show how they're linked together. So let's look at a deoxyribonucleotide. So we'll use the 5-carbon sugar that goes with the DNA, which is deoxyribose. So here's the 5-carbon sugar, and I would draw it, let's see, let's just draw the whole thing here. So a hydroxyl group there, and a carbon, and then 2 hydrogens here. Now I'm not looking at anything, going from my memory here, so let's see if I can avoid making any mistakes. So we have a carbon here, oxygen here, carbon here, and then 2 more carbons down here. So there should be 5 carbons here. And I don't know who came up with the numbering system, but use this little prime with these numbers. So 1 prime for this carbon, 2 prime for that one, 3 prime, 4 prime, 5 prime. And these numbers are so important because we always are talking about 5 prime and 3 prime directions in genetics, and this is where these 5 prime and 3 primes come from. So these carbons right here are the most important, the 5 prime and the 3 prime carbon. So we're not finished yet, and this might be helpful. So normally when we draw these structures out, so we're looking at atoms here, and we're joining the atoms together with these covalent bonds, and that's what these lines indicate, covalent bonds. And if you haven't had chemistry yet, some of this stuff may seem kind of difficult, but there are some rules, and so we should have 4 bonds formed with all the carbons. So with this one right here, we only have 2 bonds, right? So there's probably going to be 2 hydrogens coming off of this guy right here. So that gives us 4 bonds there. With this carbon right here, well, we only see 2 bonds, so we know we have 2 other things there. And we are going to look at deoxyribose, right? And sometimes it's called 2 prime or 2 deoxyribose. And that's because we have a hydrogen here and not a hydroxyl. If we were looking at an RNA, this would be a hydroxyl group. So we put an OH there. So we'll put an H and an H like that. And this one here is going to have an H and an OH. So the O is attached to this bond right here. And this carbon right here, 1, 2, 3, we're just going to put an H there. So I think the important things to remember are in a 2-deoxyribose, we're going to have an OH here and an OH up here. and the rest of these extra atoms attached to the carbons are going to be hydrogens. And then you have to remember there's an oxygen here. Okay, so this is a little embarrassing. I made a little mistake. I should have had an oxygen in here. So that should be an OH. Now let's draw the base now, and we'll draw a pyrimidine because they are a little easier to draw than the purines. So I'm going to take that out of there, and I'm going to attach a nitrogen of at position 1 of the pyrimidine right here. So we have nitrogen, carbon, nitrogen. This is just the generic structure of the pyrimidine. Okay, we have something that looks like that, and let's go with cytosine. Cytosine is going to have an oxygen up here, and nope, that's going to be wrong, right? Amino group there, and oxygen double bond to this carbon down here. Now we're also going to have some double bonds here, so we'll put those in here, and then we will put in the hydrogen. So anywhere we have a carbon with only 3 bonds, we'll add a hydrogen. Okay, and nitrogens should always have 3 things bonded to them. For this nitrogen, we have 2 hydrogens up there, and we don't draw the individual bonds. In this case, we just put H2. So that looks pretty good. So we just need to add one more thing, the phosphate group, right? So we will, let's see, let's cut this thing off here, because we add the phosphate groups to the 5' carbon, and O, P, O, just like that. And so this would be a nucleotide with 1 phosphate, and we can add 2. We can add 2 more to this one too. So just repeat that structure. Okay, so we have 3 phosphates here, and this is a nucleotide that would be used by polymerase to elongate a single strand of DNA. Well, to replicate DNA, this would be a nucleotide, a cytosine nucleotide that would be used by DNA polymerase in that process. So what did we remove? The next part of the question is, where is that? What atoms are removed from the structures when the linkages are formed? So we removed a hydroxyl group from that carbon, and we removed a hydrogen from here. I didn't indicate that, but if you look at the general structure of a cytosine base, there's hydrogen there. And we also removed the hydroxyl group from down here. So those were all removed. So okay, so that's it for question 10.10.